Alright, y'all, so today we're going to talk about limits at infinite discontinuities, so write that down, also known as limits at vertical asymptotes. So that's the title of your notes. You need to know, based on yesterday, we wrote this down yesterday, infinite discontinuities is the same thing as vertical asymptotes. We named the three types of discontinuities yesterday. Those two are the same. Okay, so, and then I would write this down. Finding limits, actually you don't need to write this down, but we are going to find limits at vertical asymptotes without a calculator. Okay, cool. So let's get started. I'm reading right here. Suppose we are asked to find the limit of the function. We did not do the exploration today without a calculator. So we need to find the limit of this function. Okay, we can't simplify by factoring. Well, first of all, how do we know we need a factor? What do we need to do to check that we need a factor? First thing we want to try is always what? Tell me. In the box, tell me. What should you try first to solve limits? Always. Go. Okay, so hopefully you said substitution. We should always try substitution first. So we're going to do 2 plus 5 over 2 minus 2 equals 2 times 2 is 4 plus 5 is 9 over 0. Uh-oh. Divide by 0. No, we're not allowed to do that. Okay, so our next step would be to factor and cancel out this x minus 2, right? But we actually can't simplify this one by factoring and crossing out the x minus 2 term because you can't factor the top. You can't factor 2x plus 5. So if we could cross out, just so you know, you need to write this down. If you can cross out a factor, you have a whole. This double little arrow thing means this implies there's a whole. But we cannot cross out. So what do we have instead of a whole? We have a asymptote, or an asymptote. And specifically, we have a vertical asymptote. So you could write vertical asymptote at x equals 2. Because 2 is where the issue happens, right? When we plug in 2, problems happen. Okay, cool. So how the heck do we find this limit? We can't simplify. What should we do? Okay, so since we are dealing with a vertical asymptote, there are 3 possibilities for the limit. You need to write down, with vertical asymptotes, there will always be 3 possibilities. Write these possibilities down. You could just write this sentence and then write 1, 2, 3. You don't have to write like limit equals every time. Okay, here's our 3 possibilities. Either the limit equals positive infinity, or the limit equals negative infinity, or the limit does not exist. When we have vertical asymptotes, those are our 3 possibilities, and remember this means different limits. If you have does not exist, you would get different limits from left and right. Oops, left and right side. That's what does not exist means. Okay, now let's break it down. How do we know which one is the right one? We know these are 3 possibilities. How do we check which one we have? Okay, how to figure out which possibility is the right answer. All right, you need to make sure you write this down. When you have a vertical asymptote, you are going to plug in values on either side, and I mean left or right, on either side of the x value that you're approaching. Okay, how to figure out which possibility is the right answer? Plug in values on either side, the left and the right of the x value that you're approaching, and then do a sign test. This is a big buzzword in calculus, sign test or buzz phrase. You're going to do a sign test to determine the value of the limit. So to determine the limit. Okay, now I'm going to show you how to do a sign test. So let's do an example. We actually only have 2 examples and then notes are done. So make sure you get this down. This is like our strategy. Plug in values on either side, the left and right, of the x value that you're approaching, and do a sign test to determine the limit. Cool, so the first example is the one that we started with. Write this down. Find the limit as x approaches 2 of the function 2x plus 5 over x minus 2. Okay, we already talked about how we know there is a vertical asymptote. So we know there's a vertical asymptote. That means we need to do the sign test. So we're going to start with plugging in a value to the left of x equals 2. All right, really quick, let's think about a number line. Here's x equals 2. What would be just barely to the left of that? Like 1.9, right? That would be just to the left. Let's do just to the right. What would be just to the right? 2.1. So when I say plug in a value to the left of x equals 2, I mean think about plugging in 1.9. So here's what we're going to write. The limit as x approaches 2 of 2x plus 5 over x minus 2, all I did was copy the problem, is approximately the same as the limit as x approaches 2, or sorry, left of 2, as x approaches 1.9, 2x plus 5 over x minus 2. Okay, how do I know that that's true? So really quick, let's just talk about that. How do I know that's true? So I'm going to kind of like sketch an example of what this graph might look like. It might not be perfect, but we're going to pretend. Okay, so let's pretend that this is 1, 2, and we have an asymptote at x equals 2, a vertical asymptote. There's only a couple, actually, you know what, y'all? Here, I'm sorry. Let's go back in our notes. I want y'all to draw what these look like on graphs. So we're next to these 3 possibilities, let's draw what they would look like. The limit equaling positive infinity. This is just going to be helpful for us to visualize. We're going to put the asymptote at x equals 2, and we're going to draw what the limit like equaling positive infinity would look like. Let's pretend that the pink is the function. Okay, the limit as x approaches 2 equals positive infinity would look like this. Right? Both the left and the right side of the limit are going to positive infinity. They're going up forever. Okay, let's draw negative infinity. 1, 2. So we have an asymptote at 2. The limit equaling negative infinity would look something like this. Our function, f of x, will look something like this. They're both approaching negative infinity. Negative, negative. Both sides, the left and the right, are going down. The y value is headed towards negative in both directions. All right, and then the last one, I'm going to put it right here. 1, 2. If the limit did not exist, that would mean the left and the right approach different values. Maybe the left approaches positive infinity, and the right side approaches negative infinity. This limit would be d and e. Does not exist. Because one approaches positive, the left side approaches positive, the right side approaches negative. Okay, so these are our 3 possibilities. That's why we're checking what does the limit look like just to the left of 2 on the example. And then we're going to check what does the limit look like just on the right of 2. And it's called a sign test because we only care about the sign. We only care about the signs. on the left and the right. Okay, here we go. Let's finish this example. Sorry about that little tangent. So, just to the left of 2, we're plugging in 1.9 right now. 1.9 equals, okay, because we only care about the sign, don't solve this all the way. We're just going to think about the sign. So we're going to plug in, substitute, 1.9 plus 5 over, because we can substitute for limits, 1.9 minus 2. All right, remember, we just care about the sign. So what would the sign of the top be? Positive times a positive. This is a positive times a positive. That means positive plus a positive. The top piece of this limit equals a positive number. We do not care what number. We just care about the sign. That's the top. Now let's do the denominator. Over, what does the bottom look like? We have 1.9 minus 2. 1.9 smaller, so the bottom's going to be a negative. Positive over negative number. All right. Positive over negative. Let's simplify the sign. Equals, what does a positive over a negative turn into? Positive divided by negative is a negative number. All right, we know that the limit from the left of 2, is a negative number. So that means that it looks something like this. That limit is going down, negative, to the negative direction, from the left. Cool, now let's do from 2.1, just to the right. All right, right of 2, right of x equals 2. Again, we're going to use 2.1. The limit as x approaches 2 of 2x plus 5 over x minus 2. Oh, sorry. This was supposed to say 2 to the left, or 2 from the left. And this now we're doing 2 from the right. 2 from the right is approximately the same as the limit as x approaches just to the right of 2, which is 2.1 of 2x plus 5 over x minus 2, which equals, now we can substitute, so we get 2.1 plus 5 over 2.1 minus 2. And again, we only care about signs. We only care about the signs. So let's do the top, the numerator. Positive times a positive plus a positive. That gives us a positive number. And now let's do the bottom. This is a bigger number than 2, so we're going to end up with a positive on the bottom. 2.1 minus 2 is a positive number. And what will that equal? Positive over positive gives us positive number. So the limit from the right, again, this one was left. This one's right. The limit from the right gives us a positive. So it looks like this. So what is the general limit? The limit, we were trying to find the general limit over here. The limit as x approaches 2 of 2x plus 5 over x minus 2 equals d and e, because the limit from the left is not the same as the limit from the right. Okay, let's see. So let's go ahead and move on to this one. I'm going to do one more example and then y'all will practice. All right, in this one I'm going to go through fast, since I went through the last one pretty slow. All right, find the limit, and I'm going to actually ask for y'all's input. So find this limit. We know that there's a problem at x equals 3. How do we know that? Because if we plug in 3, we get 3 minus 3 on the bottom, which gives us 0 on the bottom, and we're not allowed to divide by 0. So we do have a vertical asymptote. Now let's actually find these limits from the left and right. So left of 3, and again I'll draw my number line. Just to the left of 3 would be 2.9. Just to the right of 3 would be 3.1. So left of 3, we're going to write the limit as x approaches 3 from the left-hand side of 2x over x minus 3 squared is approximately equal to the limit as x approaches a number that's just to the left of 3 is 2.9 of 2x over x minus 3 squared. Okay, cool. I want you to tell me, what do you get? Remember, only tell me about the signs. We're doing a sign test. So do you get a positive number, or a negative number after solving this limit? Go. Okay, so you should have plugged in 2.9. So you get 2.9 over 2.9 minus 3 squared, and we get a positive on top. So positive number equals positive number on top over, and then if we look at this, we have a negative, but the negative is squared. A negative squared turns into a positive, so we have a positive number on bottom. So your answer should have been, after solving that limit, you get a positive number. Positive number on the left-hand side. So we're approaching positive infinity on the left. If we wanted to draw it, it would look like this. What are we approaching? 3. 1, 2, 3. Asymptote is at 3. And then the left-hand side is going up to positive infinity. Cool. Now let's do the right-hand side. Right of 3. The limit as x approaches 3 from the right of 2x over x minus 3 squared is approximately, ooh, that was rough, is approximately equal to the limit as x approaches 3.1, which is just to the right of 3, 2x, x minus 3 squared equals, okay, tell me, do you get a positive or a negative number? Go. Okay, so we're going to do plug in 3.1, and you get 3.1 minus 3 squared on the bottom equals, on top, we have a positive times a positive, which is a positive. On bottom, we have, this is a positive, 3.1 minus 3 squared gives us a positive number. So our overall right limit is a positive number. So that means on our graph, on the right of 3, our limit is also positive. So what is the general limit? Let's conclude. So the limit, the one that we were looking for originally, limit as x approaches 3 of 2x over x minus 3 squared equals, okay, when you get the same thing, positive, positive, let's go back up. What were our options again? Our options for limits were positive infinity, negative infinity, or does not exist. We already saw it does not exist. If you get both positives, your answer is positive infinity. If you get both negatives, your answer is negative infinity. So down here, we have 2 positives. Our answer is positive infinity to that general limit. All right, and that's notes for today, y'all.